Welcome to Carlton's Math Corner. Today we're going to be talking about fractions and mixed numbers. At this time, make sure that you have your math journal out as well as your vocabulary packet. To begin, what do you notice? What do you notice in this? Well, I hope you said that there is a section that is shaded yellow, and there's a section shaded in blue, and then where they overlap, do you notice that there is green and then some dots that are in there to show that overlapping? Well, here's a few questions for you. What fraction represents the yellow rows that are shaded? Okay, so notice this rectangle is separated into rows, and it looks like there are 5 different rows, and it is separated into 3 columns. So how much is shaded in yellow when you just look at the rows? Yeah, exactly. There are 2 rows that are shaded in yellow. Now, can you tell me how many total rows are there? Because if I want to create a fraction, I need to know the part out of the whole amount. And so how many total rows are there? Yep, 5. There are 5 total rows. So 2/5 would represent a fraction showing how many rows are shaded yellow. How about blue? How many columns are shaded blue? Excellent. Those of you that said that there are 1 column that is shaded blue, you are correct. And how many total columns are there? Yes, there are 3. 3 total columns. So here's 1, here's 2, here's 3. Okay, so our fraction that represents how many columns are shaded blue is 1/3, or 1 out of 3. Now, can you tell me where they overlap? Can you tell me how many boxes are green? Because where they overlap, it creates a color of green. And so how many boxes are green out of how many total boxes that are in the rectangle? Yes, there are 2 boxes that are green. And how many total are in the rectangle? Let me go back up again so you can count. How many total boxes? Yes, there are 15 boxes. So if I want to create a fraction for that, it would be 2/15. So my question for you is, what can we do with these 2 fractions to get 2/15? How about look at the numerator. We got an answer of 2. Look at the numerators on top of these 2 fractions. What did we do with those numbers to get 2? Yeah, those of you that said we took 2 times 1 would get us to 2. Now, what did we do with the 5 and the 3, the denominators, to get to 15? Yes, if you take 5 times 3, we get to 15. So 2 times 1 is 2, and 5 times 3 is 15. Nice job. Our target today is that you can multiply fractions without a calculator. And so when we looked at these 2 fractions, we had 2/5 and we had 1/3. And we were multiplying them together. That's why we multiplied 2 times 1 to get 2 and 5 times 3 to get 15. So this drawing, or this model, I should say, represents what a multiplication problem looks like with fractions. So a cross is showing the first fraction, 2/5, because there are 2 shaded out of 5 rows. And then the 1/3 basically is going the other way. So 1 column out of the 3 columns. And multiplication is actually, where do they overlap? Okay, and so today we're going to be looking at different problems, such as this one. And I want you to notice, what are some things that I am doing? First of all, why am I putting an orange box around the numerators and a red box around the denominators? And then what is happening? Why am I crossing a 2 and a 10 out and putting 1 and a 5? Okay, so the orange box is basically to show that both of these are numerators. The red box is to show that these two are denominators. Okay, that's basically what the boxes are for. And it doesn't matter if they're colored or not. It's just nice to separate them from each other so that you can focus on the numerators together and the denominators together. Now, looking at this section where it has the 2 crossed off and the 10 crossed off, why do you think the 2 is crossed off and then, do you notice I have one numerator? There's 2 numerators here. I crossed off one of them, and I crossed off one denominator. And where did the 5 and the 1 and the 5 come from? Exactly. If I have 2, let me write the 2 over here. So this 2 that was crossed off, I'm going to write it over here. And if I write over here the 10, do you notice that if I take one numerator and one denominator, it doesn't matter which 2 I take, but I have to take the 10. Do you notice that it creates a fraction, 2/10? Now, where does the 1/5 come from? Now, if you're thinking that, hey, 1/5 is equivalent to 2/10, you are right. What did you do to the 2 and the 10 to get to 1 and 5? Exactly. If we divide by 2, so 2 divided by 2 is 1, and 10 divided by 2, it equals 5. Nice job. So basically what is going on here is we are simplifying if we can. So if we find a numerator that goes along with a denominator, we can put them together and we can simplify them, like create another fraction. So like 2/10 would be a fraction that you're creating, and you're simplifying that. Why do you think we need to simplify? Yeah, it basically is just to make our numbers smaller, because sometimes we have really large numbers in our fractions. I know these are smaller numbers, but this is because I want to start off with an example that have smaller numbers, okay? But not every fraction is going to have small numbers to work with. And so if I look at this, I have now simplified it, so now it's a 1, and this 10 is now a 5. So I've made it in simplest terms for 10 or 2/10. Now, so here's my new numbers. I have 1, that's my new numerator, and then a 2, I still have that one. And then I have denominators, I have a 3, and my new number is 5. So how am I getting an answer of 2 and 15? So 2/15. Where did that come from? What am I doing with the 1 and the 2 and the 3 and the 5 to get to 2/15? You're absolutely right. We're multiplying. We are just multiplying straight across. 1 times 2 is 2. 3 times 5 is 15. Okay, so let's try another problem. But before I do that, let's talk about what are the steps that we did. First of all, we put a box around the numerators, a box around the denominators. Okay, so that's step number 1. Then we chose one numerator and one denominator. So if there is a number on the top out of our numerators that go along with a number on the bottom, our denominators, we can put them together and then simplify them. So that's step number 2, is to try to simplify them. Now what we cannot do is we can't choose 2 denominators to try to simplify them. You know, if both of these were 10, we can't simplify them because one has to be out of this box and one has to be out of this box. So one has to be a numerator and one has to be a denominator. And then our last step, our third step, was we just multiplied our numerators. So we multiply straight across. 1 times 2 is 2. And then multiply our denominators. 3 times 5 is 15. Okay, so let's try another problem. What if I have 11/12 times 5/22? First of all, our first step is to do what? Yes, put boxes around numerators, boxes around denominators. So that's what I did. I put a box around them so I keep them separate. Now, second step is to choose one numerator, one denominator. Do you notice any numerators that could go with a denominator down here? Yeah, what about the 11 and the 22? What number goes into both of them? 11 and 22. Yes, 11 goes into both of them. What's 11 divided by 11? 1. And what's 22 divided by 11? 2. So look what happens. I crossed off the 11, I put 1, and I crossed off 22, and I put 2. Because that's our next step, is to simplify. Now, 5 and 12, do you think those two go together? Is there a number that goes into both of them? No. So I'm going to leave it as is, and I'm going to do my last step. I'm going to multiply straight across. 1 times 5 is 5, and 12 times 2 is 24. So my answer is 5/24. How about the next one? Let's put boxes around our numerator and denominator. Then any numbers that go together, 1 from the top, 1 from the bottom. So I noticed that an 8 and 32 go together. What goes into 8 and what goes into 32? Well, they both share the number 8. 8 is the biggest number that goes into both of them. So if I take 8 divided by 8 is 1, and 32 divided by 8 is 4. Now, do you notice that 9 and 27 also go together? What goes into 9 and 27? 9. So this is what happens. It goes into there once, and 9 goes into 27 3 times. So we really simplified it. And if I multiply straight across, 1 times 1 is 1, and 3 times 4 is 12. So our final answer was 1/12. And so let's just look at our work again. So we got 1/12 as an answer. And so at this time, what I want you to do is I want you to try 4 problems. Will you please multiply these fractions for our ticket problems tomorrow? Remember, follow the 3 steps, and I know you can do anything that you put your mind to. So thank you for joining me at Carleton's Math Corner. I look forward to meeting with you again.